in this part of chemistry, we are going to talk about concentration in solutions. Okay, we understand that solutions are homogeneous mixtures. They have solute and solvent. And we have example of solutions. We have, like here, if we have a lot of, a container of water, and inside it is dissolved sugar or dissolved salt, we cannot distinguish between the solute and the solvent particles. So that means here the solute particles, which are sugar, the solute particles that are what? Sugar with less amount, and also the solvent particles, which are what? Water. So in this case, this one we call it solution, since it is a homogeneous mixture. Homogeneous mixture, that means we cannot distinguish its solute particles from its solvent particles. So we see it, the whole solution, as one consistency, as one, unity. So this solution now, it has solute and solvent. And we can have another container of water here, and also we put inside it sugar. What will be the difference then in this solution and this solution? So we have here a container that is, for example, here 500 milliliter, and here we have also 500 what? Milliliter. 500 also milliliter. And it is also water, and here the same dissolved water. So what would be the difference between these two containers? So one of them will be higher concentrated, one will be less, or they're going to be equal. What do we mean by concentration? So concentration, it means the amount of solute particles. What is the amount of solute particles that are dissolved in the solvent or in the solution as whole? So this amount now, is it high, a small amount, big amount? So this amount that we need exactly to know, it will be given as a number in order to distinguish between what? The solutions. So we have four main indicators, or four main ways to get this concentration as a number. And when I mean concentration, that means what is the amount of solute particles inside the whole solution, or what is the amount of solute particles inside the solvent alone. Okay, here for example, if you remember, when you have a cup of tea, sometimes the tea that you received is light. So that means there is less number of tea particles inside it. Then you ask sometimes to make it more concentrated. So when you make it more concentrated, so that means more tea particles, you need them to be inside that water. That means more solute particles. So that means it's going to be higher or more concentrated. That means more concentrated means more particles of solute inside that what? Solution. Okay, how we know this one as numbers now? We have four things. We have concentration by mass, and we have concentration by volume, and we have molarity, and we have molality. So you have four of these ones, four indicators or four ways to find the concentration of a solution. Okay, for concentration by mass, just we find the mass of solute, the mass of solute over the mass of solution. Over the mass of what? Of solution. As a percent, we write it as what? As a percent. What percent is the solute particles of the whole solution? Is it 5%? Is it 10%? Is it 20%? Okay, this is now we use mass, but sometimes mass is not easy for us, or it's gonna make us, we're gonna like if it needs, or it's gonna be a higher difficulty to do it. So in this case, we go to another mean, which is, for example, here what's concentration by volume. Concentration by volume, it is the volume of solute, the volume of solute over the volume of what? Of solution. And pay attention now, we write in the denominator here solution, and here what? Solution. Okay, what about molarity and molality? molarity and molality. In molarity, it is here number of solute, as you see. So all of them, the numerator is solute in general. So because we are, trying to find the percentage of that solute or compared to the solvent of solution. So that means solute up. But here we use mass, and here we use volume of the solute, but here we use number of moles. We use number of what? Of moles of the solute. And we know what 1 mole means. 1 mole of atoms or molecules, it is Avogadro's number of atoms there. Over here, over volume of the solution, but in liters. In what? In liters. So that means molarity, and it's the most used, by the way, it's number of moles of the solute over volume of the solution. Volume of what? Of the solution in liters. In liter what? Unit. Okay, what about molality? It's the same here, number of moles of solute. Same thing like molarity, but the denominator here, it's the mass. Look, it's the mass of what? Of solvent. Of what? Of solvent. And this is the only one that it is what? Solvent in the denominator. Well, this one is solution. This one is solution. This one is what? Solution in the denominator. Okay, here now, mass of the solvent. And here, number of moles of what? Solute. So these ones now are the ways that we use them to find the solute and solvent. Okay, if we take an example here, If we have here a solution and we have like 10 grams of solute. 10 grams of solute. And we have 90 grams of solvent. What is the concentration by mass? What is concentration by mass for the solution? It's going to be, as we said, mass of solute, which is 10, over mass of what? Is it over 90, which is mass of solvent? No, because the denominator here has to be the solution. And the solution in general, the solution, it means solute plus solvent. Solute plus solvent will represent the whole what? Solution. So 90 plus 10 is going to be 100. So that means it's going to be what? 100. 10 over 100, it means what? 10%. So that means now the ratio of the mass of solute compared to the mass of the whole solution, it is 10%. Okay, what about if we change just this one now, instead of grams, we write it what? Liter. We write it here what? Liter. That means we are talking about volume. So concentration of volume will gonna be volume of solute, which is 10 over volume of solution. And volume of solution, that means the whole solution means solute plus what? Plus solvent. So that means it's going to be over 100. That means it's going to be what? 10%. Okay, what about if we are talking about molarity and molality? Molarity and molality, we need number of moles of solute, number of moles, and we need the volume of what? Of solution. Okay, you're going to take it here, an example. Here we have a solution. A number of moles of the solute is, for example, 3 moles. Is 3 moles. And the volume of the solution is, for example, 6 liters. Find the molarity. Molarity is capital M. So we know that molarity, it equals moles of solute, which is 3, over volume of the whole solution, in what? In liters. So it's going to be over 6. That means it's going to be 0.5 molarity, capital M. 0.5 molarity, it means for every 1 liter of a solution, there is half mole. There is what? Half mole. And this is what does that number mean. Okay, what about if it is molality here? If it is molality, just same thing here. Number of solute, for example, here is the same here. Number of solute number of moles of solute. And just we have solvent. Solvent, it can be the solvent, it can be water, and anything else. So solvent here is, for example, here 12 grams or 12 kilograms. In this case, how can we find the molality? Molality is a small m. Molality is number of solute moles. What is the number of solute moles here? This is another example, by the way. Just we use the same number here as number of solute moles, which is 3. So we divide 3 over the mass of solvent, not the mass of solution, mass of solvent alone, which is what, 12. So 3 over 12, very simplified, is going to be 1 over 4. That means it's going to be 0.25 small m. 0.25 molality. Molality. Okay, now we go to last point of this part here. As we know here, this one here, you ordered in a restaurant tea, and they gave you what? A cup of tea. And as we know, cup of tea, that means water, and inside it tea. We will ignore here sugar. So that means here now, this is tea, and inside it you will get what? Sugar, tea particles. You'll get what? Tea particles. These tea particles, if it is light, that means less number of particles inside. And you need it to be more concentrated. What are you going to say? You're going to say, okay, could you please change this one to be more concentrated? Okay, at this case, what will the waiter do, or what will the one who prepared it, what he gonna do in this case in order to make it more concentrated? What he gonna do? He gonna add more sugar particles inside. More tea particles inside it, right? If he add more tea, that means he is adding more solute particles to the same solution. In this case, it's going to be more concentrated. So this is now how to change it to be more concentrated. So if you want to change the solution to be more concentrated, you need to add more solute particles, while the solvent particles, which are the water particles here, remain the same. We didn't change the quantity of water here. Just we added more sugar to it. That means more solute particles. Okay, if we are doing the opposite, if you are in a restaurant or in a cafe, you order then a tea, they give you this tea now with particles of tea that are a lot more than you need. So that means it's more concentrated tea. And you don't want it to be more concentrated. You want it to be less concentrated. What are you going to do here in this case? You're going to tell them, could you please make the concentration less? That means what they're going to do in this case? What will they do to make it less concentrated? They're going to dilute. What does it mean, dilute? They're going to dilute the solution. Diluting or dilution means to decrease the concentration. So they're going to dilute this tea, this cup of tea. That means they're going to make dilution process, and dilution process, that means they're going to make it less concentrated. Okay, how are they going to do that? In this case, it's going to be the opposite of the previous one. So that means they'll add now more what? More water to it. When they add more water, that means they are adding more solute or more solvent. They are adding more solvent. Okay, when they add, you will have, that means the new solution is going to be like this here now. This is the new cup now, where you'll have more water, and number of tea particles is not changed. It remains the same. So that means when we dilute a solution, that means we add more solvent, while number of solute particles, which are tea, we're going to leave them as they are. So that means it's not changed. Okay, in this case now, we're gonna see what will be the result. This solution now, or this tea at the beginning, it has molarity. And molarity means number of moles, right, of solute of solute, right? Over what? Over liters, which is volume of what? Of solution in liters, right? Volume of solution. So this, it has molarity here. Call it molarity 1. And here now, this one here, it has also molarity, and its molarity will be the same, M2. Number of moles of solute over what? Over volume of what? Of solution in liter. Okay, look here now. Will the molarity of the previous one here, will it be different from the one here? Will the molarity of the first solution of the first T you received and the second one after they diluted that, will it be the same molarity? No, it will not be the same molarity. Why? Because now the denominator is changed. The volume of the solution is changed, because now what they did, they increased the solvent. That means they increased the volume of solution in general. Okay, now the question that is here important. Did they change number of moles of solute? Did they change it? Number of particles of sugar? No, they didn't. So that means now in dilution process, number of moles of solute is not changed. It remains the same. But what is it changed? The volume of the solution, where the solvent itself. The solvent will increase. That means the volume of solution will increase. So that means number of moles here will be the same like numbers of moles of here. Okay, can we restate this formula while we put number of moles of solute to be the subject? Okay, that means what will be this one now? It's going to be number of solute, what? Moles. Number of what? Of solute moles over, it equals what here? Molarity 1 times, this will make it what? Volume 1. Okay, while the second one here, what's going to be? Same thing. Number of solute moles, it equals what? M1, M2, yes, which is molarity for the second cup of tea times what? Times V2, which is the volume of the new solution. In this case now we said, in dilution, number of solute particles in the first time and in the second time will remain the same. So if this one now, this side equals this side, what does that mean? That means this side equals this side. If you have two equations and left side are equal, so that means the right side will be equals. That means what will we get now? That M1 times V1 equals M2 V2. M2, and this is now the dilution process formula. That means molarity of the first solution times its volume, it equals molarity of the second solution after it is diluted times its what? Its volume. And we're going to use these ones in questions related. I hope you understand now what is concentration and what is it used and how can or what are the ways that we can use them. Thank you so much. See you then.